Have you ever looked up at the night sky and wondered whether the greatest mystery in our solar system has been hiding in plain sight all along? Most people would point toward Mars, the icy moons of Jupiter, or the distant worlds beyond Neptune. But what if the strangest planet is actually the brilliant object that shines just after sunset, so bright that ancient civilizations worshipped it for thousands of years? That world is Venus. For generations, scientists believed they understood it. A planet almost the same size as Earth. A rocky world born from the same cloud of gas and dust. So similar that it earned the nickname Earth's twin. But the closer we looked, the more that simple picture began to fall apart. Today, Venus is revealing active volcanoes, mysterious dark clouds, unexplained chemistry, and atmospheric behavior that refuses to fit into existing models. Every new discovery seems to replace one mystery with three more, leaving researchers with a surprising question. What is really happening on our closest planetary neighbor? And why does it seem determined to challenge everything we thought we knew? To understand why scientists are so fascinated by Venus today, we have to travel back to a time when nobody had ever seen its surface. Unlike Mars, Venus hides behind an endless blanket of thick clouds. Even the most powerful optical telescopes reveal almost nothing except a bright white sphere. For centuries, that smooth appearance allowed imagination to fill in the blanks. Some astronomers pictured vast oceans stretching across the planet. Others imagined endless jungles hidden beneath the clouds. Science fiction writers filled their stories with giant plants, mysterious creatures, and lost civilizations living on a warm tropical world only a short distance from Earth. It seemed like a reasonable idea. After all, Venus is nearly the same size as our planet, with a similar mass and a similar composition. If Earth became a living world, why couldn't Venus have done the same? The mystery remained unsolved until the space age finally allowed humanity to visit another planet. In 1962, a small spacecraft quietly changed planetary science forever. As it approached Venus, its instruments began sending measurements back across millions of kilometers of empty space. Scientists expected warm temperatures, perhaps even conditions suitable for liquid water. Instead, the numbers coming back were almost impossible to believe. The surface wasn't warm. It was hot enough to melt lead. Temperatures reached around 425 degrees Celsius, making Venus hotter than Mercury despite being much farther from the Sun. The atmosphere wasn't gentle either. It was crushing. Standing on the surface of Venus would expose you to pressures roughly 90 times greater than Earth's sea-level atmosphere, similar to being deep beneath the ocean while surrounded by air so dense that it behaves almost like a fluid. In just one flyby, centuries of assumptions disappeared. Venus wasn't Earth's paradise. It was one of the most hostile environments in the entire solar system. Scientists soon realized that the thick atmosphere was trapping enormous amounts of heat through a runaway greenhouse effect. Sunlight entered the atmosphere, warmed the surface, and the escaping heat became trapped beneath layers of carbon dioxide in clouds filled with sulfuric acid droplets. The planet had effectively become a gigantic pressure cooker with almost no way for heat to escape. For many researchers, the case seemed closed. Venus was simply a dead world. Interesting, perhaps, but no longer mysterious. That conclusion would survive for decades. As more spacecraft visited the planet, they discovered endless volcanic plains, enormous mountains, and countless impact craters. The landscape appeared ancient and frozen in time. The accepted theory suggested that hundreds of millions of years ago, Venus experienced a massive volcanic resurfacing event. Lava spread across huge regions of the planet, covering older terrain before geological activity slowly faded away. According to this picture, Venus was no longer changing. It had become a fossil. A silent planet preserving the remains of an ancient catastrophe. And because almost everyone accepted that explanation, very few people thought to question it. Sometimes the biggest discoveries begin with someone asking an unexpected question. In the early 1990s, radar instruments aboard an orbiting spacecraft created the most detailed maps of Venus ever produced. Since ordinary cameras couldn't see through the thick clouds, scientists used radio waves instead. The radar signals passed through the atmosphere, bounced off the surface, and returned with information about mountains, valleys, lava flows, and volcanoes hidden below. The mission successfully mapped almost the entire planet. Then it ended. The images were archived and stored away. For nearly 30 years, they remained largely unchanged. Until one planetary scientist decided to examine them again. Instead of looking at Venus as a single picture, he compared images of exactly the same locations taken months apart. It was careful work. Hour after hour, image after image, almost everything looked identical. Nothing moved. Nothing changed. Exactly what everyone expected. Then one volcano refused to cooperate. High on the slopes of Mont Mons, one of the tallest volcanoes on Venus, a volcanic vent appeared different. Earlier images showed a relatively circular opening with steep walls. Months later, that same vent had expanded dramatically. Its shape had changed. The interior looked filled. Nearby terrain appeared brighter, consistent with fresh volcanic material spreading across the landscape. The difference wasn't subtle. It was visible. If the interpretation was correct, the eruption happened while the spacecraft was actually orbiting Venus. That single observation carried enormous implications. If one active eruption could be captured almost by accident during a relatively short mission, then Venus might not be geologically quiet at all. Instead of a fossil world, it could be an active planet continuously reshaping itself beneath its permanent cloud cover. Later studies examining the same radar archive identified additional locations showing signs consistent with recent lava flows, strengthening the idea that volcanic activity may still be common across the planet. Suddenly, Venus looked alive again. Not alive in the biological sense. Alive in the geological sense. Its interior still moving. Its surface still changing. Its volcanoes still building new landscapes where scientists once expected only ancient rock. And that discovery led researchers toward an even deeper mystery. Because if volcanoes are still active today, they could be influencing the atmosphere in ways nobody fully understands. And the atmosphere of Venus may be the strangest place in the entire solar system. If the surface of Venus is hidden beneath an endless blanket of clouds, then the atmosphere becomes the only place where scientists can watch the planet in action. And the more they observe it, the more confusing the picture becomes. At first glance, Venus looks surprisingly simple. Viewed through visible light, it appears as a smooth white sphere with almost no recognizable features. There are no obvious continents, no swirling hurricanes like those on Jupiter, and no colorful bands like the giant planets. Just a bright, uniform world reflecting sunlight back into space. But change the wavelength, and Venus transforms completely. In ultraviolet light, enormous dark streaks suddenly appear across the cloud tops. They twist, stretch, merge, and separate like giant shadows drifting around the entire planet. These patterns race through the atmosphere at speeds approaching 360 kilometers per hour, completing a journey around Venus in only a few days. Scientists first noticed these mysterious markings nearly a century ago. They expected that decades of research would eventually reveal their identity. Instead, the mystery only deepened. Even today, nobody can say with complete confidence what creates these dark regions. Researchers simply call the phenomenon the unknown ultraviolet absorber. The name sounds simple, but its importance is enormous. Measurements suggest this mysterious material absorbs more than half of the solar energy reaching Venus. That means it plays a major role in controlling the planet's temperature, atmospheric circulation, and weather patterns. Imagine trying to understand Earth's climate while having no idea what the sun is. That is similar to the challenge facing planetary scientists studying Venus. Many explanations have been proposed. Some researchers believe unusual sulfur compounds may be responsible. Others suggest iron-rich minerals suspended inside the clouds. Still others investigate complex chemical reactions driven by sunlight. Laboratory experiments have successfully recreated several substances that behave similarly under Venus-like conditions, making each explanation scientifically plausible. But plausible is not the same as proven. Every answer seems to leave another question behind. And that pattern repeats throughout the Venusian atmosphere. Normally, planetary atmospheres tend toward chemical balance. Given enough time, reactions settle into predictable patterns where substances are continuously created and destroyed at roughly equal rates. Venus refuses to cooperate. Sulfur dioxide behaves in unexpected ways, disappearing from cloud layers where models predict it should be abundant. Water vapor appears in concentrations that are difficult to reproduce through existing atmospheric simulations. Tiny particles suspended within the clouds remain chemically uncertain despite decades of analysis. Even more surprising, researchers have detected trace amounts of gases existing together in combinations that should quickly react and disappear. According to current chemistry, some of these molecules should cancel each other out almost immediately. Yet they continue to appear. Something keeps replacing them. The obvious explanation would be volcanic activity. Active volcanoes release gases into planetary atmospheres all the time. But when scientists compare observed gas levels with expected volcanic cycles, the relationship is far from straightforward. The chemistry refuses to follow simple rules. Every solution introduces another contradiction. Then came one announcement that instantly captured headlines around the world. In 2020, a team of astronomers reported evidence for a molecule called phosphine high within the clouds of Venus. On Earth, phosphine is extremely unusual. It is associated primarily with industrial processes and certain biological environments where oxygen is scarce. Because of that connection, some researchers have considered phosphine a potential biosignature, a molecule that might hint at biological activity under the right conditions. The discovery generated enormous excitement. Could something unexpected be happening inside the clouds of Venus? Scientists responded exactly as science should. They checked the data. They repeated the analysis. Independent teams searched for the same signal using different instruments. Soon questions began to emerge. Some researchers argued the original measurements had been overestimated. Others suggested calibration issues might have created the appearance of a stronger signal than actually existed. Several observations failed to detect phosphine at all. For many people outside science, the story seemed finished. Mystery solved. False alarm. But research rarely moves in straight lines. Later observations hinted that a much weaker signal might still be present. Not strong enough to prove the original claim. Not absent enough to completely dismiss it. Instead, Venus once again occupied an uncomfortable middle ground where evidence pointed in multiple directions at the same time. That uncertainty is frustrating. But it is also one of the most exciting parts of scientific discovery. Sometimes the answer is simply that we do not know yet. And Venus has become a planet full of unanswered questions. If you enjoyed this journey through one of the solar system's greatest puzzles, let us know your thoughts in the comments. Which mystery fascinates you the most? The active volcanoes, the strange atmospheric chemistry, the unidentified ultraviolet absorber, or the possibility that future missions will completely rewrite everything we think we know? Your perspective could inspire the next great discussion. And if you're passionate about deep space mysteries, hidden worlds, black holes, galaxies, and the latest discoveries from modern astronomy, stay curious, because the universe always has another story waiting to be told.